As we wrap up section 9.6 in our chapter, finishing the chapter on rational expressions, we're going to talk about solving rational equations today. Methods to do this, we can have two scenarios. We can either have a fraction equals a fraction on each side of the equation, in which case we are going to cross multiply or use the cross product and find our value for x. And then remember, when we find our values for x, we have to check our answer and make sure that the solution is not one of the restrictions on the problem. The second method that we could use is when we have multiple rational expressions, more than one on each side. We're going to find the LCD of each side, and then we're going to multiply each side by the LCD, and then make sure we distribute it to each term of the problem. We might be able to cancel some factors out then, which eliminates the fraction, and then we're going to solve that resulting equation. So once again, you got to check your answer to make sure your solution is not one of the restrictions. So I have 6 examples here to show us and to kind of walk through the different possible scenarios of this problem. Okay, let's look at our first one. First scenario, we have a fraction equals a fraction. So we're going to use the cross products of the means and the extremes. Just so you remember, the means are the ones on this diagonal, and the extremes are the ones on the green diagonal. So the product of the means and the extremes, x minus 1 times x plus 4 equals 2 times 3, which will be 6. We're going to distribute our left-hand side and get x squared plus 4x minus 1x minus 4 equals 6. Let's set it all equal to 0. Bring the 6 over and have minus 10 equals 0. Let's take that and factor that to x plus 5 and x minus 2. And then let's solve each of those and get negative 5 and positive 2. Now, we do need to consider what are the possible restrictions on the problem. Well, the original problem had a x minus 1 in the denominator, so x cannot be equal to negative or to positive 1, but that's not one of our restrictions, and so our solution is going to be, as we've written, negative 5 and 2. Our next problem, we look in example 2. Once again, we have a fraction equals a fraction, and so we're going to multiply the product of the means and the extremes. Once again, I'll circle the means are the ones in the middle, and the extremes are the ones the very first and the last. So let's multiply this. 5 times x plus 3 equals 8 times x. That leaves us with 5x plus 15 equals 8x. We subtract 5x from both sides, so we have 3x equals 15 and x equals 5. Because we have a 5 and an 8 in the original denominator, there are no restrictions, and my answer is merely x equals 5. So in these first 2 examples, we have a very simple scenario of the product of the means and the extremes, cross-multiplying, some people might say, and then making sure that our answers do check in the problem. So let's check each of these answers to make sure that they work. Okay, let's go back to our first example. When I plug in negative 5, I get 2 over negative 6 equals negative 1 over 3. That's negative 1/3 equals negative 1/3. Trying the value 2, we get 2 over 2 minus 1, or 1, equals 6 over 3. And once again, that's 2 equals 2. So both of those check. Let's come over here and check on example 2. On example 2, we have 5 over 5 equals 5 plus 3, or 8 over 8. So that also checks. So we're just trying to make sure that our answers are the correct ones. Let's move down to our second page. On our second page, we don't have a fraction equals a fraction, so we're going to have to find the LCD. On example 3, the LCD between 2x and 3x is 6x. So we're going to multiply each side of the equation by 6x. So 3 over 2x minus 5 over 3x. Then we're going to multiply the other side of the equation also by 6x. Let's distribute now. 6x times 3 is 18x over 2x minus 30x over 3x equals 12x. Now the reason that we're multiplying by the LCD is to cancel our fractions. So on our next line we can see the 18 and the 2 cancel to a 9, and the x's cancel as well. Here, the 30 and the 3 cancel to a 10, and the x cancels as well. And that leaves us equal to 12x. So I have negative 1 equals 12x, and x equals negative 1/12. So there's my solution. It's not a restriction because the only restriction is that x cannot be equal to 0. Let's look at example 4. Our LCD on example 4 is going to be between 2x, 3, x, and 6. So my LCD is going to be 6x once again. So this time I'm going to write the multiple of the LCD into each multiplier. So we have 5 times 6x over 2x minus 2 times 6x over 3 equals 1 times 6x over x plus 5 times 6x over 6. I find sometimes it's easier to write it in towards each term instead of multiplying them out like we did on example 3, because now it might be easier to cancel. The 6x and the 2n's cancel to a 3. That gives us 15. The 6 and the 3 cancel to a 2. That gives us 4x. The x and the x cancel. That leaves us 6. And the 6 and the 6 cancel. That leaves us 5x. Let's move the 6 over to the left and get 9. Let's move the 4x over to the right and get 9x. And that leaves us with a value of x equals 1. In our original problem, we have 2x on the bottom and we have x on the bottom. So our restriction is only x cannot be equal to 0. That means if we were to plug in the value 1, which we can do right now, we'll see that it works. 5 over 2 times 1 minus 2/3 equals 1 plus 5/6. I'm going to convert this all into sixths. 15/6 minus 4/6 equals 11/6. And that does check because 1 equals 6/6. All right, so x equals 1 on that one. Let's look at our last two. Our last two, we have binomials in the denominators. So we're going to have a binomial times a binomial as my LCD. So my LCD in example 5 will be, very simply, x plus 1 times x minus 2. So I'm going to multiply that times each of my fractions. X times x plus 1 times x minus 2 all over x plus 1 plus x times x plus 1 times x minus 2 all over x minus 2 equals 2 times x plus 1 times x minus 2. Now remember, the purpose of multiplying by the LCD is to cancel. So the x plus 1's cancel. That leaves you with x times x minus 2. Here, the x minus 2's cancels. That leaves you with x times x plus 1. And this equals 2 times x plus 1 times x minus 2. Now we're going to need to distribute, and we're going to have a quadratic problem that we can solve from there. X squared minus 2x plus x squared plus 1x equals 2 times x squared minus 2x plus 1x minus 2. Our right side, x squared minus 1x minus 2 equals 2x squared minus 2x minus 2. On our left side, we have 2x squared minus 1x. Nice about this problem is the 2x squareds cancel out. That leaves me with minus 1x equals minus 2x minus 2. I'm going to add minus 2x over, giving me 1x equals negative 2. Now let's go back to our original problem. We have a denominator of x plus 1. That means x cannot be equal to negative 1. We have another denominator of x minus 2. That means x cannot be equal to positive 2. So our value of negative 2 is perfectly fine as a solution. Be careful on these kind of problems with your detail. 1 plus or minus obviously can be crucial as you work it out. Example 6 is a unique example. It's brought intentionally to understand and reintroduce the idea of opposites. Before we work the problem out, I want you to notice that we're probably going to need to factor the denominator on the right. So let's factor this denominator. Hopefully you see it's x minus 4 and x plus 3. Now, our original problem is 2 over x plus 3 minus 3 over 4 minus x. A couple days ago, we had problem 40 on the homework assignment where we talked about the idea of opposites. And x minus 4 and 4 minus x are opposites. So what we can do here is we can change the minus out front to a positive, and we can change the 4 minus x in the denominator to x minus 4. This is going to allow us to have a very straightforward LCD of x plus 3 times x minus 4. Let's multiply each fraction by that LCD. 2 times x plus 3, x minus 4, over the original x plus 3. Plus 3 times x plus 3 times x minus 4 times the original over x minus 4 equals 2 times x plus 3 times x minus 4 over the original x minus 4 x plus 3. Remember, the whole purpose of multiplying by these LCDs is to cancel out common factors. So here we have 2x minus 8. The x minus 4's cancel, leaving me 3x plus 9. And here we have a canceling party, leaving me just a value of 2. On the left side, I've got 5x minus 1 equals 2. That means 5x equals 3, so x equals 3/5. We could plug this back in if we wanted to with our calculators to try to figure this out, but our only restrictions on this problem are -3 and +4. Neither of them are 3/5, and so that is going to be our correct solution on this problem. So I hope you see that we have got two different methods to work as we're doing these problems. Method number 1 is if you only have two fractions equal to each other, cross multiply and solve the new equation. Method number 2, multiplying by the LCD to try to eliminate our fractions, causing a simpler problem at the major middle step of the next half of the problem. All right, our homework here in 9.6 is 7 through 15, and then 45, 47, and 49. Hopefully you find this a good challenge, but also very doable as we wrap up our chapter.